In section 3.4, we're going to look at how to graph polynomial functions. Now, we're not going to do this 100% on the graphing calculator because I'm going to want to see a little bit more process, but we are going to use the graphing calculator as a tool quite a bit, so you can kind of follow along there. So the first thing is just a quick little preview of sort of the different shapes that the different degrees of functions are going to make. We know obviously what a parabola looks like, so that would be an x squared. Now, if we look at these different powers as we increase, we want to maybe notice some patterns here. I'm just adding in my axes to these graphs. There we go. And you can graph these really precisely in your graphing calculators, but I'm going to give you just kind of a quick overview. So in x to the third, we've seen a cubic before. The graph looks something like this, okay? And x to the fourth ends up looking a lot like a parabola, but what ends up being a little bit interesting here is it comes down and it curves a little flatter at the bottom. It's not quite as sharp of a turn as a parabola does. Now in x to the fifth, it turns out, looks really similar to x to the third, but it is going to do the same thing. It's going to come down through here, and it's going to be a little bit flatter at the part where it turns around. And then x to the sixth is going to be similar to x to the fourth, but that one is going to be even flatter when it gets to the bottom of the U. Now, I hinted at this yesterday when we talked about multiplicity. So each of those would have a 0 at 0, an x-intercept at 0. But as the multiplicity gets higher, the graph ends up getting flatter where that 0 is. And that's what we're going to see happen all the time. What I want you to notice is that all of the ones that had odd powers, and you can include x to the first in there because we know what that looks like, that's a line, the arrows go in opposite directions. On one side it's going up and on one side it's going down. And all of the ones that have even powers, and again include a parabola in that, both of the arrows are pointing the same direction. That's kind of an important observation to make there. And all of our, we can consider all of them in this sort of a way with all of the transformations that we are going to use. Now notice we're saying n is greater than or equal to 3. If it wasn't, it would be a parabola, and it would be a line if it was 1 or 2. If it was 0, it would just end up being a constant. So we're talking about polynomials that are bigger than a quadratic in this section. Now, this is just a refresher over your transformation rules. So if we have a value of a that is greater than 1, that's a vertical stretch. If it's less than 1, it's a vertical shrink. And then if it's negative, that causes an x-axis reflection. And then if you remember h and k, those are the ones that give us the shift either left, right, or up and down. So those rules look like this. And notice we're talking about the value of h. So if the formula is x minus h and h is positive, then it's just going to look like x minus h. If I substitute a positive 2 in there, it's not going to change the sign. It'll still be x minus 2. So whenever you see a minus, that means it moves right h units. And if it has a negative value for h, we end up subtracting a negative, which turns it into a plus. And so that's when it ends up moving left. And then when we go up and down, if k is positive, it goes up. If k is negative, it goes down. So those are just kind of a quick little refresher, helpful things to keep in mind. Now, what we want to look at also is end behavior, meaning what do the arrows do? Now, this notation, as x approaches positive infinity, we need to make sure that we understand what that means. So let's look at a graph for just a second. If I have a graph that, say, looks like this, on the x-axis, if we are moving to the right, positive infinity is going to be on this side. If we're moving to the left, negative infinity is going to be on this side. Now, similarly with the y-axis, as I move up, I am heading towards positive infinity, and I am heading down towards negative infinity. So if I want to say as x approaches positive infinity, that arrow means approaches, that means we're asking what happens as my x values move out this way. Okay, and so we use that notation to describe end behavior. If I have a graph, for example, that looks like this, alrighty, I want to know what happens as my x approaches positive infinity. So I can say as x approaches positive infinity, I want to know what the f of x, or the y value, what that does. So we're looking here. As my x gets bigger and bigger this way, what is my y value doing? And we can see the arrow's pointing up, so the y value is going up, and it is approaching positive infinity. On the other side, as x approaches negative infinity, that would be moving this direction. What are my y's doing? Well, that arrow is also going up, and so f of x is approaching positive infinity. So that is how you read that notation, okay? They don't have to go the same way. If my arrow was pointing down, then I would say towards negative infinity. So when we look at these rules for end behavior, if you remember from Algebra 2, we looked at end behavior. The two things that we need to look at are the leading coefficient of the polynomial, and we need to look at the degree of the polynomial, okay? So the leading coefficient, if the leading coefficient is positive and there is an odd degree, this is kind of like a table here. Whoops, there we go. Okay, so if the leading coefficient is positive and the degree is odd, your graph is always going to look like this, down, up. And that's how we practice it in Algebra 2, is drawing arrows. So let's think about that, what that means. As x approaches positive infinity, so that means as I move towards the right, what is my graph doing? Well, the right side arrow goes up. So that means that f of x is approaching also positive infinity. Whoops, sorry about the bell. And then as x approaches negative infinity, the left arrow is going down, so we would say f of x approaches negative infinity. Okay? If we change the sign, if that leading coefficient, and remember that is a, the leading coefficient when you look at your transformations, if the leading coefficient is negative, that causes a reflection, so it switches the direction of our arrows, which means it's going to switch our rule as well. As x approaches positive infinity, f of x is going to approach negative infinity, and as x approaches negative infinity, f of x is going to approach positive infinity. Now with an even degree, the arrows always go the same. We saw that at the beginning. So they either go up, up, or they go down, down, depending on whether the leading coefficient is positive or negative. If they both go up, then that means in both of these cases, we're going to approach positive infinity. And if they both go down, then in both of these cases, we're going to approach negative infinity. All right, so there's kind of a summary of the characteristics that we're going to use as we look at our polynomials.